Good evening, everyone.
Good
Good
evening.
evening.
Yeah, so we'll be waiting for 5 more minutes, maybe. Let more people join in, then we'll start. Till then, you can just log in to join PD and get ready.
Sure, sir.
I hope you all can see the code, right?
Yes, sir, it's visible.
Okay.
We will be touching all the different varieties of questions, right? So, like grade of week 11.
Yeah, we'll be discussing as much possible the variety we'll try to cover.
Okay, sir.
So, anyone in the session who hasn't gone through the lecture still now? Have you all completed the seeing the lectures?
Completed the lecture, sir.
Okay. So all in the session have a fair bit of idea about distributions, right? The whatever have been covered in week 11. Or anyone who has any specific doubt in any kind of distribution. So maybe when we'll discuss those questions, we'll try to explain it a bit detailed way. Is there anyone who has any specific doubt in any specific kind of distributions or something? Okay, I don't think any more are joining as of now. So let's start with the session. Okay? Uh, Okay, so these are basically if anybody who is new to peer deck, anyone who is new to peer deck who doesn't know how to join PD, or have you all logged in?
So we block it.
Okay, so there is a missed one question. Okay, so these are some of the tips for this to solve the questions of today. Like first thing is that you should identify each trials and see whether you can classify it as a success or failure. So these are the kind of things you should try to map. Whatever the question should be, you should try to map either it to be success or failure, and that would help you in solving questions either in Bernoulli or it can be binomial distributions. Okay, and the other thing is see if the total number of the trials is fixed or not. and see if each trial is independent of the other trials or not, and that would actually give you IID distribution. So all these things keep in mind while you are reading the question, and see what you can implement on individual cases. Okay.
Yes, sir.
Okay. So this is the first question. So from this, these are three options, and you have to find out which of this is not a binomial experiment, or basically which which you can't model as a binomial distribution variable, maybe that.
So there are no options for this question.
I think you should see options.
No
Other,
answers were configured for
no, sir,
this
no
question.
options. Okay, but I think there were. So you can see the slides, right?
Yes, sir. Slides are
Means
visible.
no, in Join PD you can see the slides, but you're not getting an option where means select an option. Is
Yes.
it okay? As of now, you can just type it in the chat box. Okay. Whatever options do you feel, just individually type it in the chat box. Then we'll discuss each option. Okay, so maximum of them are saying third option, that it's not a binomial. Can anybody just explain why is it so?
So because it's said that we without replacement. So without replacement, the probabilities will not be identical or similar. Probabilities will change depending on the previous uh, uh, trial. So that is why it's not a binomial experiment.
Okay, so you're saying the experiment is because 5 balls randomly containing 20 yellow, we are choosing out 5 balls and we are doing it without replacement. So the probability for red balls chosen, each red ball would be different. That's why you are saying that it should not be binomial. Is it so?
Yes.
Okay. Anyone, any other solution to this, or any other reasoning behind this?
They are not independent events on the third option.
Okay, the same thing. It's like if there is no replacement, then automatically whatever ball you have chosen in the first draw, then automatically for the second draw that ball won't be available and it would impact, right? Okay. Others, anybody with the third option, means any reasoning for the third option? Like, do you find anything else? Okay, so let's start moving from the first option itself. Okay. The first option says that tossing an unbiased coin for 100 times and counting the number of heads. So as I was talking about that initial slide of the tips, that how can you segregate into smaller observations? Like first thing is, how many trials do you see in the first experiment?
100.
There are 100 trials, right? And then for each trial, what should either that can be a success or a failure. That is,
Right.
it depends. Like you can take maybe success head as your success or tail as your success, and that doesn't matter to us. But whatever it is, that we can model it out. Like for example, one of the heads to be a success and let's say tail to be failure. So this is two things we are getting it. So anything else do you need to consider it as a binomial random variable? First,
Independent and identical. Those are the two
first,
things.
first thing is our n is fixed, that is 100. Now the second thing is, for each trial we are getting either it is success or a failure, and then there's one more thing that because it is given the coin is unbiased. So whatever I think Chetan was saying for the third option, that also automatically get applies to the first option, that for every trial will have the same probability of head as well as tail, because unbiased means it will be 0.5, 0.5. So to sum it up for each means all these points, you can say that all the trials are independent and identical. So my total distribution would become independent and identical distribution. So in total, you can say that this will be a binomial. We can frame it to be a binomial random variable or binomial distribution, whatever. Anyone, any doubt with the first option, like whatever we have discussed till now? Or how, what are IID samples? Anything, any doubt regarding all this?
No, sir.
Okay, so we'll move to the second one. Second one, what does it say? That tossing a fair coin for 100 times and counting the number of heads. Okay, so in this case and in the first case, is there any difference? Can you find out any difference?
No, sir.
Like anyone else, anything? Do you think there any difference in the first question and in the first option and the second option,
No, sir.
or it is just the word play?
What? It's just a word difference.
Fair coin
Unbiased
and
and fair.
unbiased and fair same.
Yeah, exactly. It is just instead of unbiased, we are talking about a fair coin, right? So now we'll move to the third option. Now, as we segregated for the first and the second, can anybody, whatever points we were discussing for the first and second, can you just frame the similar points for experiment 3 also? Like
So,
first is
for the third option, we have 20 yellow balls and 20 red balls, and we choose 5 balls randomly. So it will depend on which 5 balls we choose. So the number of red balls that we can have, it depends on that. So it is not an independent event. It depends on that particular event. And
independent, that part is okay, but the first thing I think you should see, because it's we are checking for what, binomial experiment, right? Or
yes, sir.
binomial distribution. So the first thing you should always go for is that is the number of trials fixed or not, because the binomial distribution will only hold for when you have fixed number of trials. If you are going for infinite trials, then it doesn't make sense. Okay, so
Okay.
first thing is over here my trials are fixed, right?
Yes,
Yes,
the
sir.
trials are fixed, there are only 5 trials, and it can either be a red or a yellow. The only problem is it's without replacement, so the probability keeps changing.
So the probability keeps changing. So as I think Chetan was saying, that we can sum it up that these all trials are not independent of each other, or even if identical also, because if the probability is changing, then in every trial, let's say if you are finding out the probability of red balls, in every trial it would be different, right? For example, in the first trial it would be something 20 by 40. In the second trial it would become 19 by 40, right?
Yes,
Yes,
sir.
sir. So, but
So
if it
that
was with the
sorry,
replacement, it would
19
be
by
I
39.
know, right?
yeah, 19 by 39 for the second trial, and similarly for the others.
So, but if it was with replacement, it would be a binomial.
Sure.
Yes.
Yeah. Again, we can just frame it up in the same way that let's say my probability of success is getting a red ball and maybe the failure is a yellow ball. And then I can do it the same way, just 20 by 40 may be success, and similarly 20 by 40 for failure also. And then we can again frame it to be a binomial random variable with my number of trials would be n, that is 5. And
5.
then probability of success would be 1 by 2, and probability of failure would be again 1 by 2. Okay.
Yes, sir. Yes, sir.
So I'll move to the next one. So that is what in the solution also we'll see the same things, just in wordings it is written. So as we are talking about that experiment 3, first thing is you should always check for if your number of trials is fixed or not, and then just try to frame it out in the success or failure, and it would be then you can get an idea that either it is a binomial or not. Okay, so now the second question what we are going to do, keep in mind these things, that what is the distribution formula for a binomial case? That is if you have n number of trials, then we'll be doing n choose I. So what does what is I signifying over here?
The value the random variable
Success.
can take.
Value the random variable will take, or you can tell it that number of success also, and that would
Yes.
be to the probability to the power that, right? Let's say if in 10 trials, if I'm having let's say 4 success, then it would be p to the power 4. That is 4 independent trials which we got success, right? And the
Yes,
others
sir.
would be failure. That would be 1 minus p to the power n minus I. N is the number of trials, and subtracting out the successes, we'll get the failures, right?
Yes, sir.
So keep this in mind, just, and then try to solve this second one. Yeah. Can you all see the options for this question? I mean, are you getting a box to type your
Yes, sir.
write down your answer?
Yes, sir.
Okay. Okay. Okay, so the answer for this, whatever you have given a scattered distribution, like there are so many different answers. One clue I can give you is that the answer won't be more than 0.5. Okay, so just recalculate whoever has whatever who has given these answers. Just try to recalculate, or maybe to be more precise, I'll say the answer is less than 0.25. Okay, so check your calculations again, whatever method you're using, and see. And others also try to solve it. I think only 50% have responded. Others, even if you just the basic formula which you discussed in the last slide, just try to implement it and see. Even if you give wrong answer, it will give you an idea how to approach this question. Unless you solve it, you will not get an idea. Okay, anyone still trying, or shall we move to the solution? Okay, so yeah, anyone is saying something?
Yes, I wanted to tell you to if we could move to the solution.
Sorry, can you just repeat once more? What did you say?
No, no, sir. I just wanted you to go to solution,
Okay.
finish
Hmm.
solving.
Okay, so basically the question says that there's a trainer who wants to test the skills of his students, and the condition is that there's a circular board of 20 meters, and then you have to hit it in between less than 5 meters, that is in that center area. Then only he will consider you to be means that case would be, or that trial would consider to be a success, or else it would be a failure. So the first thing is over here again, what kind of distribution this is giving you an idea about?
Binomial distribution.
Binomial
Yeah.
distribution.
Binomial, because if you again see the 2 3 points to keep in mind, that the first thing is there are 3 trials, fixed number of trials are there, and then every time if it is less than 5 meters, then we'll consider it to be a success. If it is greater than 5 meters, it is going to be a failure. So these things are giving us an idea that we have to design it to be a binomial distribution. Now coming to the second part, can anybody tell me what should be the probability of success in this case? Sorry?
1 by
1 by
4.
16.
1 by 4.
Oh, 1 by 4. Sorry. I was getting in
1 by 4. Okay, how did you do that?
5 by 20.
Sir,
Sir,
if he
sir,
hits,
it'll be 1 by 16, not 1 by 4. 1 by 16.
1 by 16. Okay. Okay, whatever, whoever said 1 by 4, what's the logic behind it? And whoever is saying 1 by 16, tell me the reason behind it.
sir,
Why do you
if the
say?
student hits the board under the 5 meter,
Mhm.
then it will be the probability of success. Here the
Correct.
given that the size of the board was 20 meters and he
Okay.
has to be hit the board under 5 meters. So
Mhm.
then 5 upon 20, it's 1 by 4.
Okay, the thing is, logic wise, it's not the right approach, because there is one more thing, that it's a circular board, right? It's not,
Area.
if it would have been a linear, for example, let's say just a linear, maybe a thread or something, let's say thread of 20 meters, and then you have to hit in the fire, means if you can mark something, or if you can hit, or whatever it is, less than 5 meters, you could have said it that way, that there are these possible infinite ways of doing it. But in this case, you have to consider it to be area, because it's a whole circular thing, right? Now, if it's a circular thing, not only in one direction you can hit, right? You can hit in the whole area of the under that 5 meter zone.
Yes, sir. So
So
the
Yes, sir, got it.
area of
in this,
with
in
radius
the
20.
in this cases, it may be a circle, it may be a rectangle, whatever the geometrical figures are. Whenever you get such cases where there will be infinite number of points, right? In what happens in general cases, we have a particular fixed number of sample space, fixed sample space, right? That is, maybe there are total, like for example, in the last case where you did, there were 20 color balls, whatever, irrespective of the color, there were 20 color balls, and out of this there were 40 color balls, and out of this 20 were red and 20 were yellow. So we had fixed numbers, but over here we have infinite number of points. So whenever you have such cases where there will be infinite number of points, just whatever may be the geometrical figure, always consider the area in case of calculating the probability values. Okay. So my probability of success would become that is pi r square.
1 by
That
60.
would be
By
uh,
60.
divided by pi 20 square. Is that clear? So that would
Sir.
give out to be, I think that whoever was saying 1 by 16, that would
Yes,
give
sir.
out to 0.0625 something similar to that. Okay. So after that, once we get that is for our binomial distribution, one property is getting the probability of success, and another property is getting the number of trials, right?
Yes, sir.
Now, one more thing is probability of failure. I think you can easily calculate it. Right? That is 1 minus 0.625. You have to just do it, and it would come out to be something 0.9375. Now the second thing that comes is, what are, if my x is a random variable, that is the binomial distribution, where, tell me, the question says that what is the probability that a normal student will pass the test? And in this part of the question, if you see that the student undergoes 3 trials and need to get at least 2 success out of 3 to pass the test. So what are the possible random values that my random variable x will take if that is passing the test is my whole
Zero.
2 or
3.
2 or
And
3,
3.
right? Because at least 2 successes we need. So if my x is the random variable that is following binomial distribution, then either it can be that I will get out of 3 trials 2 successes, or he can get maybe 3 successes out of 3 trials itself. Right. So we'll be finding out probability of x equals to 2 plus probability of x equals to 3. Till this, is it clear to all? That is, probability of passing the test would be equals to probability of x equals to 2 plus probability of x equals to 3. Let me take you to that slide also. This is the first part, and so this is what I was talking about. The probability of passing the test will be, and this is my capital random variable x equals to I. Okay, so this is the probability by which my random variable would be taking maybe 2 successes out of 3 trials or 3 successes out of 3 trials. And my in total probability of passing the test will be just summing up those x equals to 2 and x equals to 3. Till this, is it clear to all?
Yes, sir.
Okay.
Please
So
go back
then
to the question slide. 1 second.
the previous one.
Yes.
Yeah.
Sir.
It is just calculating the formula as I was talking about this total
No, sir.
area.
No, sir. The question slide.
Okay.
Yes, sir. Got it. Thank you.
Okay. Okay. So after this, just you have to plug in the formulas, right? So for let's say for probability of x equals to 2, what would my formula look like?
So 3C2 into 1 upon 16 to the power 2 into 15 upon 16.
Correct. So it would be for the first case x equals to 2, it would be 3C2 into 1 by 16 to the power 2 into
15 upon 16.
15 upon 16 to the power 1. And similarly for x equals to 3, it would be C3 choose 3 multiplied by 1 by 16 to the power 3.
Yeah.
And
1
then,
upon 16 to the power 3.
Oh, yeah, 1 upon 16 to the power 3 multiplied by 15 upon 16 to the power 0.
Yes, sir.
Right. For the last case will be for x equals to 3. In the last case, that is 15 upon 16, we'll be doing to the power 0, because ultimately out of 3 tiles, we have already got 3 success only, right?
Yes.
So if you just see this part, as I was talking about this part, that is 0.9375 to the power 0, because already out of 3 tiles, we have got 3 success. So that would give me a total probability of passing the test to be 0.011. I think 2 or 3 people gave that response. Okay. Anyone, any more doubt in this question, or is it clear to all?
Clear, sir.
Yes.
Okay. So I'll move to the next. Okay. So for the next question, again, it will be binomial random variable only. But now what we are talking about is that expected value of binomial random variable and variance of the binomial random variable. That is the formulas we'll be using in this next question. And I think all of you know how this expected value, how to deduce this expected value, right?
Yes.
Yes, sir.
To maybe just to means even if in exam, if you're forgetting this formula for binomial case, I can tell you maybe in a shortcut way or whatever you can consider it. For example, what is the how do you calculate expected value for a variable? That is
Summation of XP.
Probability.
The probability of
Cumulative addition.
correct. Summation of x into the probability of x taking that value, right? Now,
Yes.
binomial random variable is just the summation of n number of Bernoulli random variable. Is it clear? Isn't it? What is binomial random variable in general? In general, it is the summation of the Bernoulli random variable, right?
Yes, sir.
Yes, sir.
Now, for one Bernoulli random variable, what should be the expected value? Bernoulli random variable can take exactly 2 values, right? That is 0 or 1. Now,
Yes.
the probability of 1, let's say it is p, and then probability of 0 becomes 1 minus p. So for expected value of one Bernoulli random variable, it would be just p, because it would be 1 into p plus 0 into 1 minus p. So 0 part doesn't count, and it will be just p. So now when we do it for n, it would be, if you know it from the properties of expected value, what does it say? That expected value gets added up, right? So if we are doing it for n Bernoulli random variables, then it would just become n into p. Are you getting that part?
Yes, sir.
And similarly for the variance case also, you can do it. For 1, it is pq, and it would become npq. Okay. So using just these 2 formulas, just try to solve this. Gaurav, we are talking about probability of getting 3 tails. How can you get 2.1? It has to be something less than 1, right? How can your probability value go crossing 2 point means value exceeding 1? Yeah, just check your calculations also. Okay, so again the answer would be something around from 0.25 to 0.35. Okay. If you're getting something more than that, then just reconsider your calculations, whatever you're doing. That doesn't mean you'll arbitrarily put any value. Okay. Calculate.
Sir, it is biased coin, no, sir?
It is biased coin.
But
No, it's
first,
not. Sorry. It's given unbiased coin, right? Okay, so uh, who didn't understand the question? Anybody who didn't understand the question? Do you want me to explain the question? See, the thing is, uh, over here, this will also be a binomial distribution. Okay, but
One,
what is miss? Sorry,
one clarification. Number of trials here is three, no, sir?
number of trials is
5.
3. Means
Yes, sir.
it.
Got it. Like
See,
I took it as three trials, and all the three trials are tails.
no, no, no. The thing is,
Number of
over here,
trials are 5.
what we are trying to say is that we don't know the number of trials. We just know that my random experiment is tossing an unbiased coin, and I'll be doing it, let's say, for n number of times. Okay, I don't know what is that number means, or the number of trials, and out of those number of trials, I should be getting 3 tails. Okay, so what is the probability of that 3 tails? So now the number of trials which is unknown to us, that value you have to deduce it by using these two equations, that is the variance value and the expectation value. Okay, once you get that value of the that is the number of trials, then you can utilize that formula to get the means then you can utilize the formula of normal binomial distribution to get the probability of getting exactly 3 tails out of those n trials. Is this clear now to all, how to approach this?
Yes, sir.
Yes, sir.
Okay, just try it. Everybody just try it out. I think still there is only 60% people are responding. Others, please try. Still 5 are left to respond. I said you the method also. Now just try to solve it out. See whatever value you are getting. Just try to equate the equation of variance and expectation. From there, try to find the value of n, that is the number of trials. Once you get the number of trials, just plug it in into the formula binomial distribution and try to find out the value for x equals to 3. That's it.
So one moment.
Excuse me, sir.
Yeah, say.
Sir, I just wanted to know, will you be taking the topic of Poisson distribution at the end of the class?
Okay, if you are done with the slides, then you can ask whatever you have doubt with the Poisson distribution.
Okay, sir. Thank you.
That's
Okay, so whoever has given this 0.21 and this 0.343, can you just explain me whatever approaches you have followed? Whoever gave this 0.21 or 0.343.
I found out the number of trials. After that, what should I do?
Okay, so now how much did you get the number of trials?
I am getting 5.
Okay, once you are done with number of trials, the next thing what you have to do is that the probability of getting 3 trials out of, 3 tails out of 5 trials, right? Because we have already got our trials to be 5. So
Yes.
your formula would become 5C3 multiplied by what should be the probability value of success? Because it's given an unbiased coin, right? In each trial, we are tossing an unbiased coin. So what is the probability of getting one head? Over here it is given tails as our success, let's say. So what is the probability of getting one tail?
1 by 5. In points.
1 by, sorry, 1.
0.7 it is. P value it is coming 0.7.
P value you are getting 0.7.
7.
Okay. And what is your 1 minus P? That is your P. What did you take your P over here? That is getting a tail, right?
Yes.
So then it would be 0.7 to the power 3 and then multiplied by 0.3. That is the probability of getting a head. 1 minus 0.7. So that will be 0.3 to the power 2. That would give me the probability of x equals to 3. Okay. Maybe I'll move to the solution part. So see the probability of, as I was talking about, the expected value of x and variance of x is given to us, right? So from there, we know that expected value of x is n into p, that would be 3.5. And then variance of x would be n into p into 1.5. So we are already getting these 2 equations. Now what we'll do, just to get the value of n, what we can do is that we'll divide these 2 equations so that we do have the n and p part is common, right? So what that would give us 1 minus p and equivalent to 0.3, that is dividing equation 2 by 1. And from there we can deduce out that p comes out to a 0.7, that is the probability of getting a tail. And then putting it into the earlier equation, that is n into p equals to 3.5, we'll get the value of n to be 5. Now the last part, whoever was asking, that once we get the number of trials to be 5, what we are concerned about is getting the number of tails from 5 trials, right? So my random variable was binomial distribution. So that is x equals to 3. So that would be out of 5 trials, 5 choose 3. Then the probability of success, that is the number of tails, that would be 0.7 to the power 3. Then again multiplied by the probability of failure or probability of getting a head, 0.3. If we are getting in 3 trials tail, then obviously in the other 2 trials we'll be getting head. So that would be 0.3 to the power 2, and that would come out to 0.3087. Is this clear to all?
Sir, why was unbiased
Yes,
coin
sir.
given question, sir?
Sorry.
Sir, why was unbiased coin was mentioned in the question while this is not unbiased actually?
Okay, you are saying that the number of tiles, the variance and expectation of getting a number of
Yeah, it
tails.
should be. It should have given biased coin
Mm, yeah,
because
that,
winning of tail is 0.7. It is not 0.5, no, sir.
correct.
Asking that.
Yeah, this should be, this is a mistake in the slide actually. So yeah, it should be that means either it's a, you can write it, mention it in a biased coin, or just leave it that way only. But yeah, definitely it's not an unbiased coin. Any more doubts, anyone on this question?
No, sir.
So this is again the same thing with just the same, you have to keep in mind the formula and try to solve this one. So this question, I think 18 or 18 have logged into joint PD. All 18 should answer this one. It's you have already solved the similar questions till now, all the 3 questions. So I need answer from all 18. Till now, only 13 have responded. Others, please try to solve it. This is a very similar question to what we have been solving till now. So all should try to solve this one. These are the similar questions you'll be getting in exam also. So if you don't solve these questions, it is not going to help you. 7 more, please try to respond. Okay, anybody, can you just explain me the question so that maybe the other four, whoever haven't responded till now can maybe get an idea about how to solve this. Anyone who would like to explain how to go about this question?
Sir, for the random variable value of 4 or 0, it would be easier to solve for
No, no, just explain the question that.
Okay. Okay. So we have a fair coin, and sorry, we have a coin, and the person wants to check whether it's a fair coin or not. So for that, the probability of success and failure should be 0.5 and 0.5. So what they do is they toss that coin 4 times, and the binomial random variable x takes the value of number of heads. So given is the table of PMF of that random variable. So for 0, it would be that they tossed the coin 4 times, but they did not get any head. The number of heads was 0. So
Correct.
the PMF, sorry, 0.1296 is the probability for that. One would be that they toss the coin 4 times and they only got one head. 0.3456 is the probability for that. And similarly, 2, 3, 4 are the number of heads they get by tossing coin 4 times. And given below are their probabilities.
Correct. So basically, what the question says is that the Ritika doesn't know if it's a fair coin or not, right? So to just, what is our ultimate goal? That we have to find out that tossing a coin, what is the probability of getting a head or a tail, whatever it is. If that comes out to be 0.5, then we can just say it is a fair coin or not. Now the data given to us is of a random variable x, and that calculates the number of heads. And for that, the PMF is given as Chetan was explaining, that when x takes the value 0, that means that my number of heads is 0. So ultimately I'm getting 4 tails. Okay. So now you already know that for a binomial distribution, what is my formula? It is NCR, where R is my number of successes, multiplied by probability of success to the power R, and multiplied by 1 minus P to the power N minus R. So let's say if you can equate any of these values, let's say if you are taking, let's say probability of x equals to 0. So what you should do? You should do 4C0 multiplied by P, that is the probability of getting a head, to the power 0 into 1 minus P to the power 4. Is this clear to all?
Yes, sir.
So from there, you'll get out and you'll get an equation, and from there you can find out the probability value P. Either you can go for probability of C equals to 0, or you can go with sorry, x equals to 0, or even if you can go with x equals to 4 also, and that way you will find out the P value. So others who this 4 people, 5 people who didn't get it, I'll just give you 1 more minute. Can you just try it? Okay, so others, what was the P value did you get? Probability of getting a head?
So 0.4.
Okay, but there are a lot of variety of answers. Okay, so yes, it would actually come out to be 0.4. Okay. So as I was saying, this would be the solution. Anyone who still didn't get it, you can just follow this solution. Okay. Now, can anybody tell me there is an alternate method to do this also?
NP equal to expected.
NP equals to expected value. Okay. So Priya, how will you proceed by that?
That 0 into 1, 0.1296 plus 1 into 0.3456 as nx fixed. So 4 into multiply all those things equating, I calculated it came 1.6. 4p equal to 1.6, p equal to 0.4.
Correct. So this is through the probability we can find out, equating it to probability. And if you are not doing it through probability, then also we can do it because we have already got all the PMF values for the possible values that random variable can take. We can indirectly find out the expected value also, and we know that expected value for a binomial is equal to n into p. So from there also we can get the value of p, right? Because we already know the number of trials that is tossing the coin is we are tossing the coin 4 times. So that solution is also noted down. So anyone who didn't get that part also, just follow this slide. That because we already know my expected value for the binomial distribution is n times p, and then we know how to calculate the expected value for a binomial distribution, and that from there also we can get the p value to be 0.4. Any doubt in both the methods?
No, sir.
Sir, I did a 1 minus probability of getting no head.
Okay.
So probability of getting no head is x is equal to 0, no, sir?
Okay, so you are saying that you find means for every case did you find out that? Because when you are saying that 1 minus probability of getting no head, what do you mean? We are not concerned about getting in total how many heads, right? We are concerned about just in one trial, what is the probability of getting a head? That is unknown to us, right?
So won't that be the complement of getting no head?
No. Getting no head when we are talking about, it is the sum of all the trials we are talking about. Let's say there are
Okay.
but
Okay.
over here, what we have been asked is that in one trial, what is the probability of getting a head? Like whatever we used to do, right? Tossing a coin, either the probability of getting a head was 0.5 or let's say 0.7, like in the earlier question we got it, right? What
Yes,
you
sir.
are talking about, that is the, let's say in the 4 trials, how many heads we can get. That is a different interpretation altogether, right?
Uh,
That is, let's say out of 4 trials, if you, when you are saying that getting no heads, that means that we have got in the 4 trials 4 tails only.
okay. Over
But
here, the okay. What I was doing was putting the value in the right hand side. Actually, the right value here is on the left hand side given.
yeah. That is
Okay.
this part, that is probability of
Yes,
trial. What is the probability value, right?
yes, sir. Yes, I got it. Thank you, sir.
Okay. Well, any more doubts on you?
Yes.
Okay. So for the next question also we'll be using the same formula. Okay. So
जाके देख के आंदे हो क्या भैया?
try solving this.
Okay, I think this is a pretty simple question, right?
Yes.
Just have been given the value of n, you know the value of variance. What you have to calculate? P. So you'll get a quadratic equation. You just have to solve for P, right? Pretty simple question. I expected more responses up to this point. Okay. Okay, is everyone done with this question?
Yes, sir.
Let me check the responses 0.4, 0.6, 0.6, 0.4, 0.4, right? Okay, so what we have to do in this question, we know our variance has been given, our n is given, and what else has been given? That this is a binomial random variable for which this question has been asked. What are the possible values for p? Okay, so pretty simple. What we know is that our n is 8. How would you solve this? Okay, anyone would want to volunteer to say how they got about the solution?
So just putting the value
Sir,
in the
we-
formula NP.
NP1 minus
Basically,
Okay.
we have to solve this quadratic equation np minus np square, right?
Yes, sir.
Yes, sir. So, but I have a doubt.
Sorry?
So, I have a doubt.
Yes. Okay, well,
So,
so
when we
solution?
solve, we get 0.6 and 0.4,
Yes.
but is not 0.8 and 0.3 also possible?
We'll see. We'll just solve this and then we'll see. Okay.
Sure, sir. Sure, sir.
Our n has been given the number of trials as it has been given 8, right? And variance it's 1.92. Okay. So
Yes.
we binomial random variable is np minus np square. So substituting the values 8p minus 8p square, taking a to the other side, we get this. After that, it's just a matter of these calculations. We get this equation p square minus p minus 0.24. This equals to 0. Now, from this, we get our p to be 0.04 and 0.6, as most of you have also marked this, and that is the right solution for this question. Okay. Now there was some doubt. Somebody had a doubt, right?
Yes, sir.
What is the doubt?
So, could you go to previous slide?
The previous slide. Yes.
So, if we put the value of p as 0.8, it still satisfies the equation.
It satisfies the equation. 0.
Yes.
Sorry.
It's not
Oh, no,
satisfied.
no, 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 it's not,
Not,
it's
it's
not,
not.
okay. It's one,
It's a
okay. I
it's
thought
a
it was one.
it's a quadratic equation. So
Yes,
what we would expect is to have two solutions only, right?
yes, I got
So
it.
solutions are 0.4 and 0.6. In any case, no other solution, no other value will satisfy this equation, right?
Yes, sir,
As
yes.
the quadratic equation, only two solutions will be there. So this was a pretty simple, I think, pretty simple questions for the first session of this week. I think that's all for today's session. Any doubts in this question?
No, sir.
Okay. Yeah, I think we'll be ending this session now if there are no more doubts.
There are no questions on Poisson. Sir.
Sorry?
On Poisson distribution, we don't have any questions.
We have more sessions to take in this week. We'll definitely come up with other questions. First, what is there is this week is much lengthier than the other weeks, right? So what we thought is we'll first cover first half of this week. Then we'll in the next session we'll discuss the next half of the week. So that there is
we have a deadline tomorrow. So, sir, can you explain Poisson distribution questions? So, like, can you just solve the question from activity question of Poisson distribution?
Is the deadline tomorrow for this?
Yes, sir.
Yes, sir.
Okay, so yeah.
And
Yes.
so, what about the open sessions, sir? It was not conducted.
Sorry?
Open sessions.
When is open session is tomorrow?
No, it wasn't conducted.
It was never conducted.
Last week, Saturday, it was not conducted.
Okay. Just let me have a look at it. Okay, just give me two minutes.
Ami, lungi.
Just a moment. I'll share my screen and then we'll solve the few questions. Just a moment. Is my screen visible?
Yes, sir.
Okay, now let's go there. Okay, first coming to Poisson distribution. So when do we use this distribution? So this Poisson probability distribution, it gives us the probability of a number of events occurring in a fixed interval of time, right? It gives us the probability of number of events occurring in a fixed interval of time, right? This is the
or space.
Space, time or space. That is their space. For example, if we want to see number of, as also has been discussed in the lectures by ma'am, number of people who go to a particular place in an hour, or number of cars that are passing through a particular space, say some number of cars passing through a particular intersection in an hour, or number of flowers in the garden. So whenever we are dealing with such cases, we go for this Poisson distribution. So it's the PMF, like we have seen for all the distributions that we've come across. We need our PMF, probability mass function. This tells us the probability of variable taking this probability, right? This value PMF. PMF or for our Poisson distribution is e raised power minus lambda, lambda raised power x over x factorial, right? Where x is the value is the random variable takes. Now, what this lambda here is, this is the mean or average, right? Mean or average. Okay. Suppose if sometimes we are not given this lambda directly, we have been given a frequency distribution. Suppose sometimes it is number of in a, like we just saw, we use this Poisson distribution when we have to see something like number of events occurring in a fixed interval of time. Suppose we are looking at number of cars passing through an interval. Suppose this is the data we get, number of cars. I will just see number of cars. Either 0, 1, 2, 3, 4, 5, and greater than 6. This is there. And the number of like count for those is how many times 0 cars passed. This was 80 times. And this was 225. This was suppose 260. Suppose this was 225. And suppose 110, 70, and 30. Now, if we have to calculate lambda, our lambda is the parameter that we are mostly concerned with our Poisson distribution, right? So how do we calculate? So this lambda is nothing but our mean, lambda or mu that we had previously seen, right? So we'll see 0 into 80 plus 1 into 225 plus 2 into 260, 2 into 260 plus so on. I'm going to divide this by whatever total we get. So this is what we'll get for our lambda. This is the lambda that will be concerned with this question. Now let me take activity, like you said. Will tomorrow is the deadline for this?
Yes, sir.
So all those who will be attending the problem solving session will I think tomorrow we'll be focusing only on this later part of this week, this Poisson distribution and what else is there, hypergeometric, right? So for those who want to attend those, will mostly the questions that we'll be taking that will take tomorrow in the session, in the morning session, okay? In the problem solving. Now let's take a question from activity. So this is question number 2. I can see this is, let x denote the number of radioactive particles passing through a counter in 1 millisecond. Okay. The probability that the number of particles will not be counted is 0.1. Probability of not counted. It's how much is this? 0.01. Therefore, probability of counted, how much will this come to be? 0.99, right? This is there. What else? Assuming x follows a Poisson distribution with the parameter, okay, lambda has been given, right? Lambda is there. Find the probability that the number of particles counting during a specific time interval is 3. So what it basically has asked us, probability of x equals to 3, right? X has already been described in the question. It follows up Poisson distribution, and what we have been asked is find the probability that the number of particles counted during a specific time interval is 3. So what our lambda is this time? In questions, what I have told you that lambda is the average, right? In sometimes you are not given this average directly. You are given this n and p. Okay. In that case, what you will see, this lambda is an np. Okay. Whenever this np is given, this is your lambda. N into p, product of n and p. This is your lambda, as it's also been discussed in the lectures, I think. This is your lambda. So in this question, what is my n? 3, right? 3. And what is my p? P is 0.99. This is there. So what value I get for this? This will be 2.97. I think it's 2.97.
How is lambda n into p?
This has been, have you gone through the lectures?
Yeah,
Yes.
ma'am. In the lecture, ma'am said it's lambda by m equals to p. So that would be lambda equal to n.
It has been like, I think ma'am has gone in detail to explain this. Lambda by n has been given to be p. How this is, it's been like, I would suggest you to go once through the lecture.
Lambda by n is the like success of, if there is only one success in the time interval. That is, it's that probability.
Sorry, what I?
So lambda by n, the probability of success of only one success in the very small time
You are
interval
breaking
lambda
in.
t.
Your voice is breaking in between. Can anyone, did anyone understand what Chetan is, this Tanmay is trying to say?
Tanmay, I think, said that lambda by n is for when the time interval is very short and the number of successes is 1.
Huh.
So that is when we take lambda by n equal to p.
Right.
Tanmay, you need to rewatch that part of the lecture because that's not what ma'am meant.
That is not, yes, exactly. What I would suggest you is, we have a session tomorrow, right? And you come to the sessions. So what I would suggest you to is, once go through the lecture once again, right? Then see what ma'am has taught in brief, go through the lecture. And if still the doubt persists, so we'll be taking, tomorrow will definitely be solving only Poisson distribution and hypergeometric. Since tomorrow is the deadline and we've done this binomial and Bernoulli trials, we have studied in much detail, and now what is left is Poisson and this hypergeometric. So we'll solve those questions in the doubt clearing session, sorry, problem solving session. And still, if any doubt persists, again we have a doubt clearing session right before the deadline. So we'll be taking this. So this is for this question. There is nothing else. You just need to substitute this in the equation that we had, the PMF equation, and you will get your answer. This is for this question. There is not much about this. It's basically direct substitution. In, I think in all of most of these questions, it's basically direct substitution. And one thing, as you've all mentioned that tomorrow is the deadline. Tomorrow we'll be taking the Poisson distribution and hypergeometric in the problem solving session again in much detail. Okay, is that fine?
Okay, sir.
Okay, I think this will be like this. In this session, we covered the first half of this. We covered 2 questions from the first half of this week, that is binomial and Bernoulli. Now tomorrow we'll cover hypergeometric and Poisson distribution in the problem solving session, and that will be, I think, fine for your deadline. Since the session is in the morning only, that would be fine. Any doubts with regarding to the contents of this session?
So we are having session at 3 to 4, right?
11 to 12 and 3 to 4, 2 sessions. Yeah.
Okay.
Okay. I think this would be all for today's session. Okay. If there are no other doubts, I think I will end the session now.
Sure, sir.
Okay. Goodbye, everyone.
Thank you, sir.
Thanks, sir.
Yes, sir.
Thank you, sir.
Thank you.
You're welcome. Goodbye.